I'm trying to get all the images in the right spot. Okay, so we're going to work through the final exam for fall 2016. This is a volume of revolution. So let's start writing down what they're asking us for. So we want the region that's bounded by the graphs f of x equals x squared plus 2, and what they call it g of x. G of x equals 4 minus x squared. Okay, so they're not telling us the bounds of integration on this, so that's a clue that what we need to do is find where these two functions are going to intersect each other. Now, you can set this up also as a graph. Let's get this in focus here. Okay, so let's graph this out, right? And then actually, well, first we'll set these two equal to each other, and then we'll graph it out. So when I set these two equal, right, I'm going to say x squared plus 2 equals 4 minus x squared. Okay, then what I'm going to do is I'm going to add x squared. I'm going to subtract 2. I'm going to get 2x squared equals 2 divided by 2. X squared equals 1. Take the square root. Don't forget your two roots plus or minus 1. So these two functions intersect each other at -1 and +1. We'll also see that when we go to graph it out. You're welcome to use your graphing calculator to help you visualize this too. Okay, so my first, I've got this is 4 minus x squared, and then my next one is 2 plus x squared, and I know that they're going to intersect here and here. Plus 2. Okay. Just so that we notice. So this is the region here, the shaded region, from -1 to +1, okay, that we're going to be rotating around the various axes. So part A says we want to go around the x-axis. Here's our x-axis. And I'm just going to take a look. Part B, I'm going to look ahead. Part B says we're going to go around the line x equals -2. So this right here, watch out, x equals -2 is a vertical line. I'm going to go around this. Okay, so when I go around the x-axis, what's happening is, right, I'm creating a ring-like structure as I go around the x-axis. Okay, and then as I go around this x equals -2, I've got a ring-like structure that goes this way. Okay, so part A says, we'll do that one first. Part A says we're going around the x-axis. So where these two functions intersect each other gives us our bounds of integration. But when I go around a horizontal axis, like the x-axis, I'm taking a look at the disk or washer method. Okay, as I do this, which relies on pi r squared, right? Because what we're doing is we're creating a circle, and we're doing this slice. Like this little dx is the infinitesimally thin slice, the thickness of of the circle as we go around. Okay, but I have an outer radius and I have an inner radius. Okay, so I need to be able to take into account each of those. So my outer radius, my r outer, is going to come from this upper function here. So this upper function is creating that outside radius. So it's between here and here, right? Between this function and the axis of revolution. So my outer radius is going to be my upper function, which is 4 minus x squared. Okay. My r inner is going to be my inner function. This is this function right here, which is x squared plus 2. Okay. Now remember, when we do this, right, I've got pi r outer squared minus pi r inner squared. Let's make this squared dx. Okay, we often factor out the pi and we just say r squared minus r squared. Okay, but be very careful because we're basically subtracting out this area and this area. Okay, so when I go to do that, remember my bounds of integration are defined by where these two functions intersect, because it's just this region here that I want to be able to take a look at. So I'm going to set this up. My volume is going to equal 2 pi. I'm going to factor out my pi. I'm going to go from -1 to +1. And I'm going to go r outer squared minus r inner squared dx. Okay, so be very careful. It's squared minus squared. So this is going to be equal to pi -1 to +1. So my outer 4 minus x squared quantity squared minus x squared plus 2 quantity squared dx. Okay? And that's all we have to do. They just said to set up, okay, set up our integral here for the volume of revolution as we go around. In this case, part A was going around the x-axis. I don't have to do anything more. I don't have to square it out. I don't have to combine like terms. I don't have to do anything more than just set this up. Okay, my outer minus my inner, but it's each one individually squared because what we're doing is pi r squared minus pi r squared dx. Dx gives us our thickness of that little circle that we're trying to do. Okay, so part B says what we want to do is go about the line x equals minus 2. A common mistake that people make when they see this, they think x equals minus 2, they think it's a horizontal line. So they start drawing this, they do this really nice line, it's a horizontal line, I'm going to go around this. Be very careful, draw it out on your graph. This is x equals minus 1, this is x equals minus 2. X equals minus 2 is a vertical line. We're taking this and we're going around our vertical axis. Okay, when we go around a vertical axis, okay, we need to be thinking of the shell method. Okay, we'll just write down really quick. We're going to go from A to B. That tells us the bounds of integration, the area over which we're going to be integrating. 2 pi r. This is our circumference as we carve out that particular point, right? This is times the height, and this is dx. The height is basically the area of the function that we're trying to work through. So my radius is going to be wherever I'm at within this shape right here, okay, as I'm going through this boundary, right? And then the height is going to be upper minus the lower function. So let's write down, what our two possibilities are here. Let's think about first our radius. Okay, so the radius calculation I need to think about, right? I've got my x minus, I'm going around the axis minus 2, right? Because wherever I'm at, my x, I'm going around this axis right here, x is going to be minusing, subtracting out this part here, which ends up looking like x plus 2 is our radius. Okay. Now to calculate the height, okay, I need to be able to look at my upper function minus my lower function. Minus lower function. Okay, so my upper function in this case is 4 minus x squared minus my lower function is x squared plus 2. Okay, and I can combine these. I'm not squaring these out. This just gives me that area between those two curves, no squares. Okay, this is just this part, upper minus lower. Okay, so there's no squares involved here. Okay, which means I can 4 minus x squared minus x squared minus 2. I can distribute that negative to both of these terms, which is going to give me essentially the function 2 minus 2x squared. Okay, that gives me my height. Okay, so we're going to take all this and we're going to put it into our shell formula, which tells us about our volume. And I'm going to go same boundaries, minus 1 to positive 1. 2 pi times my radius, which we found before was x plus 2, times the height, 2 minus 2x squared, and then our thickness, dx. The 3 dimensions are going to give us our volume. And that's all we need to do in this particular case. They didn't ask us to evaluate it. They just asked us to come up with the integral for it. And that's it. So going around a vertical axis, be careful. X equals something as a vertical axis. We're using the shell method. Going around the x-axis, okay, the x-axis here, that's a horizontal line, right, x-axis. So we're going to use the disk or washer method. Okay, pi r squared for the disk or washer, 2 pi r height times dx for our shell method. Okay, and that was fall 2016. Okay, so